Okay, today we're going to be looking at the tangent ratio. This is something you probably have never seen before, but it's not too hard to figure out. So let triangle ABC be a right triangle. That's the key. It's got to be a right triangle with the acute angle A. Then the tangent of angle A is defined as the following. So you see angle A down here on the bottom. That's angle A. Then the leg opposite of A is over here. So the leg doesn't touch A at all, right? The leg adjacent to A is the leg that touches A. So then the tangent ratio is the tangent of angle A, or tan A, equals opposite, so the leg opposite angle A, divided by the leg adjacent to angle A. Now this is important because it is simply just easiest way to remember opposite over adjacent. Okay? Your angle could also be this angle up here. So this is just for this example, is that it's on the bottom. It doesn't always have to be the angle on the bottom. It could be the one up here that you're looking at. So tangent is opposite over adjacent. And so if we look at this, we need to find the tangent of S and the tangent of R. Okay? So all you do is to find tan S, you do opposite over adjacent. The opposite is 60, adjacent is 25. Now you'll notice adjacent is 25 and not 65. That's because 65 is the hypotenuse. You're looking for the leg that's adjacent to S. By the same vein, tan R is opposite, which is 25, over adjacent, which is 60. (60 over 25) gives us that tan of S is 2.4. And this would be 0.4167. All right, that's all there is to this. Not much more. We're not ready for sine. Find the value of x. Use the tangent of an acute angle to find a leg length. Okay, so in this case, now it gives us that the tangent of A is, instead of A, it's tan 31 equals opposite, which is 17, over adjacent, which is x. Now we have to solve for x. So you multiply both sides by x to get it off the bottom. That gives you x tan 31 equals 17. Now x isn't by itself yet, so you haven't solved for x. So you have to divide by the tangent of 31. So those cancel out on this side. You get x equals 17 over tan 31. Now there is a tangent button on your calculators. And so you're just going to push 17 divided by, before we do that, go into mode and make sure it's in degree mode. So the third one down is going to be degree. Okay, then you do 17 divided by tan 31, which give you 28.2927, blah, blah, blah. But the only thing that's important is you can round it off to 28.3. All right. All right. Find the height h of a lighthouse to the nearest foot. So in this case, we have tangent of 62 equals opposite, which is h, over adjacent, which is 100. Now you just have to get h by itself. How do you get rid of the 100? You're dividing it, so you multiply. This gives you 100 times the tangent of 62. Put that right in your calculator. You get that the height is 188.07. This is actually a way that they navigate on the ocean, is that when you're coming into shore, you'll see a lighthouse. Today, not so much, but back in the day, you would see a lighthouse and it would be marked on the map exactly how tall the lighthouse was. And so you would take your angle from the boat and you would know, say, that this lighthouse was 188 feet tall, and you would do your angle, take the tangent of it, to figure out how far you were from shore, to stop you from getting shipwrecked. So, fun little history fact for you. All right, use the tangent ratio to find the value of x, round to the nearest tenth. Okay, so we have 64 degrees here, and it's opposite over adjacent, so that would give you tan 64 equals 17 over x. Multiply by x, you get x tan 64 equals 17. Divide by tan 64, you get 17 over tan 64. Divide that out, you get 8.3. Next one, 43 degrees, so tan of 43 equals opposite, which is 36, over adjacent, which is x. Multiply by x, you get x tan 43 equals 36. Divide by tangent of 43, you get x equals 36 over tan 43. It gives you 38.6. And number 18, tan of 23 equals opposite, which is x, over adjacent, which is 53. Multiply both sides by 53. You get 53 tan 23 equals x. So you get x equals 22.5. Find the perimeter of the triangle. So for this one, all you really have to do is you do your tangent. So that's your opposite. So you do tangent of 36 equals opposite over adjacent, which is 49. So 49 tan 36, it gives you 35.6 on this side. Then to find this hypotenuse, you just do the Pythagorean theorem. So 35.6 squared plus 49 squared equals your hypotenuse. squared. 35.6 squared plus 49 squared gives you 3,668.36. You take the square root of that. And that gives you 60.6. The hypotenuse. Now you just add them together. 35.6 plus 49 plus 60.6 gives you 145.2. Next one. We have tangent of 71. Erase this. Have some room to work. Gives you tan 71 equals opposite, which is the 34, over adjacent, which is x, multiplied by x. X tan 71 equals 34, divided by tan 71, get x equals 34 over the tangent 71. So give you x equals 11.7. So this here is 11.7. Now to find the perimeter, we have to find this hypotenuse. So we use Pythagorean theorem. 11.7 squared plus 34 squared equals x squared. So it gives you 1292.89. Take the square root of that and you get 35.95 or 40. So this would just be 40. You add them all together. So you use 85.7. All right, number 24. We got 44, so tangent of 44 is equal to opposite, 62 over adjacent. Multiplied by x on both sides gives you x tan 44 equals 62. Divide by tan 44, you get x equals 62 over tan 44. It gives you 64.2. Then you do 62 squared plus 64.2 squared equals x squared to find the hypotenuse. It gives you 89.3 for the hypotenuse. Then you just add them all together. 64.2 plus 62 plus 89.3 gives you 215.5. All right, I believe that's it.